Hi. So as you saw from Thomas' presentation, Thomas joined Pebble before there was a design team in Pebble. Hi, I'm Liron. I'm head of design for Pebble. Can I say Pebble in design again? Probably. I joined about a year ago. And before, it's not only me, it's a whole design group, and they were fabulous, and I love them all. And before we joined, Pebble didn't really have a design team or a design organization. And to me, it stands as a great testament, I think, to how frigging amazing the engineers at Pebble are, that they were able to, and the developers, yeah, that they were able to actually pull this through for the amount of time that they did and be very, very successful in it. So, yeah, I'm not really sure why they needed us, but we came along. First thing we did was actually, I don't know if you remember this. The first thing we did was this. We got Johnny upset and a few people at Apple. It was actually validated because we know a few people at Apple. So good thing that we didn't use this one, which was the original one. Right. Yeah. And then Kickstarter happened, and a lot has changed. So I'm here to talk about what has changed from last time you were here, or more precisely, last time that we talked to you. And for the most part, I think the design changes or that you've seen and experienced on your devices, you've seen it. So you've seen it, and there's a bunch. We created a whole visual design language for the Pebble Watch. But I think if you're not well versed in design, it would be very hard to actually understand what's going on here. You might be confused, and you know, there's a lot of added technical elements. So I'm here to explain what the fuck's going on. So yeah. So first thing that happened is that we added 64 colors, and 64 colors are great. It's better than 2. And the thing with 64 colors and the thing with e-paper is that you need to kind of understand what you're doing in order to achieve design that actually works. And for me, it's just even starting at readability, right? But before that, I want to explain a little bit how we got to the design language that that you're experiencing on your Pebble Times and Pebble Time Steels. So we thought, you know, what is a good example, visual examples of visuals, art, graphics being produced with a low amount of color, small amount of colors. And 2 things popped out, which were influential, I think, very influential on developing the designs. One thing was pop art and early day comics, when just the fact that it was cheaper to print less colors and the small, low, whatever you want to call it. I'm ESL, so you probably get it by now. The low availability of color, whatever it is, produced this actually very starking, bold looking graphics, using dithering and other methods in print to actually achieve something that was very, how should I say it, interesting. The second thing was op art. And op art uses repetition of big, bold graphic shapes and color to create patterns. But it all gets a little bit better when you start adding animation to it. And all of a sudden, all these things, when you think about it, start to look like potential watch faces, right? But they're made of very, very simple elements and not a lot of color. And they give you, as a user, I think, more than something that is very elaborate. It's very readable at a glance. It's very easy to understand what's going on. Just do it, is everything running? Great. So, first thing to think about when designing with color for the Pebble is about contrast. Now, contrast can come in various forms, and I'll explain some of them. But the first one is, the obvious one, is color. As you can see, there's, on the left side, there's a bunch of colors on the screen, including fonts and the icon and the background, but they're all, in terms of tonality, very, very similar. And by tonality, I mean that if I take this picture and I turn this into black and white, you get a bunch of very similar grays. And that is problematic for two reasons. One is the fact that the screen is very, very small and usually far from you, so you want to be actually as readable as possible. And the second thing is that the e-paper screen that we're using is great for outdoors and it's very readable outdoors, but you want to build and create your designs to actually work also in low light conditions. So contrast is good. When talking about contrast, specifically in text, you can see that what our suggestion is that when you're using text, always use it with the highest contrast that you have, which is black and white. You can see it on the right example. We're trying to do it constantly. And when we do use color is when we try to accentuate something. For example, you want to color code your app. And then I'm going to get to the icon part in a minute, but we created a bunch of icons, and we would love you to create more icons like ours, or use a repository of icons that we have. The good thing about it is that it already is self-contained as black and white, basically units, and almost no matter what you put behind it, it will work, right? Just make sure that it's not really, really dark, like a dark blue. You won't see the outline, the black outline. Second form of contrast is in text. Basically, what you see there is that the left-hand side has less contrast. If it was the right font, it would even look grayer than that. And you want to emphasize the text by using thick fonts and thick lines. So if you're designing a watch face, for example, and you have a hand or something like that, try not to use really, really, really thin lines when you do that. It won't show up very nicely on the screen. Second thing is anti-aliasing. I'm sure everybody here knows what it is, but what I really want to show you now, it's clear that when you take a line and it's a straight line and you turn it around, you're gonna get very regular patterns of grays in your anti-aliasing part. So you can see here, when it's 45 degrees, you only have one line of grays. It's very particular. When it's 30 degrees, you have, I think, 2, and here it's 3. The thing is that we don't have a lot of grays, right? We have 64 colors, right? We have black, white, and 2 grays in the middle. So you want to optimize for situations like that. When you go really, really, really shallow, on the left you see stuff coming out of Photoshop. You get a really, really nice, gradation of grays, but we don't have a lot of grays, and a lot of the times the right hand is what will happen when Pebble or even if you just export a GIF file out. This is what happened. Try to do it, but fail. So we'll end up with a line that is actually very garbled looking. So you don't want to use shallow angles. And the second thing you don't want to use, the second thing you don't want to use is curved for the same reason. You're not going to get patterns, gray patterns that are repeatable, and so your line would look like it's going in and out in thickness. So you have Raster Gothic and low res as good examples of pixelated fonts, which is great. So if you were building a watch face, use either a pixelated font or fonts that are angular. Leco is a good example of an angular font, and Cobol, which you don't see here, is another very nice example of an angular font. And again, you have to believe me. But I can show it to you. I'll be here during your stay. So you can come, and I can show you specifically things, and we can actually continue this conversation. So all this culminates in basically something like this. This is a very early aha moment that we had in the design studio, where things kind of coalesce together. You have everything there. You have this kind of like very bold graphics and bold colors, angular icons. Yeah, contrast. And if you can see this is basically what happens when you take all these limitations. And for us, it's heaven because we really crave that. If you take all these limitations and start like having a bunch of icons being done together according to these limitations, you get basically what we call a graphic design language, right? There's a very distinct DNA to these fonts. You can't really mistake them for anything else. And they all work together as a system. If you're designing something like this, and we can, again, do it one-on-one, sorry. But one thing that I would not do is try to mimic circles with straight lines, for example. Now, I'm not sure. I think Heiko is going to talk about it, about curved lines. But basically, it's kind of a cheat. We can't really do Bezier curves. That's good for us, because Bezier curves would be bad, as you saw from my examples. But you can imitate curves by doing like very intricate design with dots and straight lines. Don't do that, please. I would personally come and hunt you down. The second thing that has happened is animation. Now, animation, as I'm sure you know, is not something new for Pebble. Pebble is one of the most interesting revelations I had during my first few weeks at Pebble, was to understand that there's a contrast of expectations between what the screen can do and what it appears to be able to do. Because this screen is e-paper, and because people are more familiar with e-ink because of the Kindle and stuff like that, there's an expectation that the frame rate is actually very, very low, where in fact it's not. So whenever you have animation happening on a screen like that, there's this good surprise moment happening, right? was like you're very surprised that this thing actually achieved or was able to do something like that, which is great. These are moments in design that you're looking for, right? Small moments of delight that you want to add. And so this is how hairy hands move with animation. No, this is how animation looked on the Pebble before. It's actually very, very fast. 30 can be 30 frames per second. And when the moment came for us to actually start thinking about how we're going to design, you have to understand that there's design language for graphics, but there's also design language for animation, right? So there's got to be some cohesive logic for movement on devices. So when it came the moment that we started asking ourselves how things will move on the screen, we saw this. This is a bug. It's an artifact that actually was fixed. It's not there anymore. But what you can see in slow motion is that the screen is actually tearing, right? To the untrained eye, if you don't do animation and if you don't, do stuff like that, you won't notice it when it's not slow motion. But if you do animation, you see that detail. And so what we thought was that we can take that and expand it and use it as inspiration, a starting point of inspiration for the design. So here's the first. Here's the first exploration of what an icon can look like when it moves. And it's very exaggerated here to actually prove a point or to show what's going on. And in a very similar fashion to the graphics that are very, very simple and simplified, the actual idea or logic, the algorithm that moves this animation is also very, very simple. It looks complex, but basically it's vector animation, it's vector graphics. So it's a bunch of points moving in space, but they're cascading one after another. There's a delay between the points, right? And that creates this very organic looking motion that we ended up calling spider animation. So the whole thing, Pebble design, language is very inspired by that. And you will see, as you already have, actually, if you're having, and you do, sorry. You know how it moves. And you know how prevalent it is in the operating system. Here's a very early example of what we thought would be a nice way to work with timeline. So already here you can see that the same principles apply here. And they got refined, more and more refined. So when do we use different types of animations in Pebble operating systems? There's different types of animations, and they all indicate specific processes or destinations that you're going towards. The simplest one is the stretch. Stretch is an icon moving in space. And it can be in timeline, it can be inside of your apps, it can be when you receive a notification. Anywhere that an icon travels, what happens is that it stretches a little bit, as you saw from the earlier examples. What that achieves is, granted, as I said, the refresh rate is pretty high, 30 frames per second, but to even give more than that, like a directional cue of where the screen is going or what is happening, stretch is very, very helpful in doing that, conveying where things are going towards. And here's an early example of just a test to see how this might work. And you can already see that what we thought was that it would be interesting if you have just one set of icons that you could scale up, move around the screen. Instead of changing it, right, it would morph basically into the next stage, right? As you can see here, there's this moment of morphing, which in a stretch that we really, really like. And basically everything here is morphing, right? There's this flag coming from a dot, scaling down, then creating this dismiss idea. And here's a very early test for timeline. You can see the same thing happens here when regular icons go up and down, like the same size. And here's another one where the icon actually travels and scales down. It's the same. Dot 2 animations. Dot 2 animations are animations that happen when you travel from one area of the system to a different area of the system. Now what you see here is a very simple way of looking at the architecture of Pebble. At home, the center element there, the home screen is basically the watch. And going up or down will take you to future and past, as you know. And pressing center will take you to the launcher. These are all, we consider them different elements, different system areas. And whenever you do that, there's a dot transition. And I'll show you what it is. You probably know it. Imagine this is a watch face. Right? The screen collapses into a dot, moves, and expands back into a different location, in a different location. And here's that happening with timeline, watch face. The second way dot 2 animations reveal themselves on the screen is when you get an incoming event, like a notification or a reminder. You can be anywhere in the system. You can be reading your email or something like that. You can be inside a pin, like this example here. And then you get a phone call from, who is it? Jimi Hendrix, yeah. So you get a phone call from Jimi Hendrix. The same thing happens, right? So you see there's rules that we apply to when we use each animation and each transition. The third kind of transitions that we don't use that quite often, but it's still there, is morph animations. Morph animations are used to reduce movement when you're moving between similar elements on the screen. It's easier to explain with an example, and here's an example of a weather app where basically what you have is a bunch of cards showing weather in Palo Alto and another card underneath it showing weather in Los Angeles, and you can press down and get the weather to the weather in Los Angeles, and you can see what happens. Basically the icon morphs from one shape to another shape. What this gives you is actually reduced, it's a very, very small screen, right? So anything moving really, really fast creates this, even if it's very small, moment of, where am I? And when you keep one element on screen, it actually creates a visual anchor that your eye can attach to itself to while things are moving, right? Now round. So when you think about a round screen, there's obvious problems specifically for smart devices. What the obvious problem is, and I think almost everybody here can guess it, the obvious problem is text, right? Now, before I go into that, I want to show you, imagine this is, well, you don't need to imagine, it is what it is. It's a rectangular element on the screen. And I'm asking you, how do you read it, right? So most of you would probably say, well, I just look at it and I know that it's a rectangle. I don't need to read it. It's just a symbol. But then I'll say, I'll be a little bit more weird and I'll tell you, yeah, but can you tell me, can you measure it somehow with your eyes? What's the first place that your eye travels to when you do that? I would argue that in left to right languages, this is the first place that your eye travels to in order to do that. And that is actually the first place anyway that you're parsing this symbol from. This is the place. Yeah. Luckily, text is actually built the same way. Text is also being parsed left to right, top to bottom. So if you take that and put it in a rectangular screen, it's a perfect fit, right? The form factor fits the way that, the way that you read the form factor without text is the same way that you read it with the information, right? What happens in a round screen? In a round screen, there's no corner that your eye can, attach itself to. Doesn't matter if it's, top, left, doesn't matter. What you would do if I would ask you to measure it is that your eye would basically go to the center, right, and try to see how big it is, right? Measurement, like, I don't mean measurement, right, not with centimeters and inches, but kind of like tell me how big is it, right? Is it big like a saucer, or is it big like a quarter? Your eye will go to the center first. And that doesn't work, right? For obvious reasons. They just don't fit. And it doesn't matter if you crop it or don't crop it, it just doesn't work. There's an inherent problem with the form factor and the smarts of the device. And what do I mean by the smarts of the device? If you look at this, what is a smartwatch, right? You can define it as having three, let's call it locations or areas or whatever, features. Apps, a launcher, and a watch face, right? Right. But this is also a good example of what happens on a, let's put it on a graph, right? The smarts are actually on the left-hand side. And the watch, which is what's a traditional watch like, right? Your old watches, what it's like, it's on the right-hand side, right? And if you would take all that and convert it to the form factor, you ask yourself, what happens there? Basically, that's what happens, right? And there's no wonder why people are very excited about round watches, because it fits their idea of what a watch is. This is how usually watches look. And in a sense, if you ask me, I'm not sure if everybody here knows what skeuomorphism is, but basically it's trying to emulate previous kind of technology with current technology, right? So if you think about the great example of the previous Apple iOS design language where you have stitches and all that stuff, right? Everybody talks about that and hates it today, but everybody were very excited about it then. But that's skeuomorphism, and that allows you to actually get familiar, right? It's a new kind of technology, but you get familiar with it using this kind of like it's a mental trick. But you don't really need it, right? A round watch is kind of like skeuomorphic like that, I believe, because essentially text is what actually drives the smarts. So, given that that's the situation, you'd ask yourselves, what, for example, other companies that have done round smartwatches, what would they do, right? So I did this, and it's apparent, right? You just write Moto 360, and what do you see? You see the watch face, which is, the traditional way a watch looks. What's a traditional watch? It's a watch face. And that's what you see always in their marketing materials, right? And you can say that for the new S2 as well, right? What are they putting out? They're putting out the traditional layer of what a smartwatch is, which is, you could say it's a watch face, but it's also a launcher. Why a launcher? Because it doesn't contain a lot of text. It can, be designed in a way that it wouldn't contain a lot of text. So those graphic layers are very easy to convert into round or design round. Where weird things happen is when you actually see the whole ad, and you see that the app, the smarts, the app itself, hasn't been handled, right? And here's another example. And here's the Motor 360. And here's the Urbane. And here's the problem. Right? So what do you do? How do you fix it? So first thing they do is the simplest, right? Some manufacturers, at some point, in some apps, it's not consistent. What they do is they'll do this. They'll center it. They'll center a line. But essentially, it's still a rectangular piece of text. What we did with the help of our amazing, where is he? Heiko, never mind. Amazing engineers is we were able to kind of like wrap the text around the round screen. If I go back, you can see that basically what happens is the top and bottom of the screen, even though you can read the lines, they're practically unuseful. And the reason is because they're cropped, right? So at that point, the top and the bottom of the screen are essentially noise in disguise of signal. So when you basically wrap it, you get more signal, right? So what we did first is you center align it to align with the form factor, which is centered, and then you wrap it around the screen. And then there's a problem. What happens when you try to scroll, right? If you're scrolling line by line, every time you scroll down or up, what will happen is that you'll get a reformatting of the text, right? Because what used to be 2 words in a line now has room for 3 words, and you know, every time you press down, everything moves around. So, you know, you don't scroll, you paginate. And that also works with our idea of fast interactions with your watch. Instead of like paginating line by line, not scrolling line by line, now you're paginating, right? So this is what happens. The second important thing that happens on the round is that the most amount of information you're going to get, and this is very, very obvious, is in the center of the screen, in the equator, right? That's where you're going to get the most amount of the ability to put the most text in. That calls for centered fixed focus, basically. So the focus doesn't travel, the list travels behind it, so to speak. And if you do that, then basically what happens is you get the idea that maybe it's better not to show all the information at the top and the bottom, where it will obviously be clipped if there's too much. So you're expanding information only on focus, where you have space for it, right? And when you have the ability to do it, you replace the top and bottom text with easy to read and understand icons, if it makes sense, right? Because icons obviously take less space and they can be replaced, or a good replacement for words. Here's an example of how it looks, the difference, like there's a delta here. On rectangular screens and round, you can see the same thing happens, wrapping of text. And here's an interesting one, where on the rectangular screen, we have all sorts of layouts that you can use for, this is a pin, by the way, if you don't know, this is a weather pin. There's all sorts of layouts that you can use for weather pins, or any other pin, doesn't matter. Some of them are actually centered, right? But the difference is the same as what I said right now, right? So why did we take the icon, put it up on the round? Because we wanted to utilize the most amount of space for text in the center, in the equator. And basically, that's it. I think I showed you, how we arrived at the Pebble design language, how we used limitations that we had, and also opportunities, the opportunities that we had to basically create a design that is very, very idiosyncratic, if you think about it. Not a lot of devices look like it, especially in watchland. And it's very recognizable because of that. It also utilizes the pain points and make them, I think, make something good out of them, kind of like lemonade from a bunch of lemons. So we would love you to actually take that thing and work with it. Take your apps, take your watch faces, and use this knowledge to convert them into round. And that's it.